So let's start. For those of you that doesn't know, we are a MATLAB student ambassador. So we are the connection between MathWorks and the student of Polytechnic of Milan. We organize events and we promote the community on Facebook and Instagram. The today agenda is the introduction and the rules of this competition, the tip and tricks to perform the best way of this competition, and finally the organization that we will follow in the next month. So let's start from introduction and rules. What we provide you will be a Simulink model, the top one, plus a drone, a real drone, a Parrot mini drone. And the goal of this competition is to make this drone performing a fixed path. This path will be depicted like a red line on the ground. And the goal of the competition will be to make the drone following this path with different shape during the real competition. So the structure will be, first of all, you and your group, so you have to compose a team from 3 to 5 members, will register to an online service. There will be the first phase, that is the simulation phase, where you and your team with the Simulink model will provide and will code the control algorithm for the drone. And finally, the best teams will do the drone competition, where we will provide you a real drone that you need to code in order to perform the task that we will give you. So the first phase, the registration, there is no limits of number. You have to compose a team from 3 to 5 people, as I said, and the team leader has to fill the form that we will give you at the end of this presentation. You can find the link in the description of the video, and so only the team leader will compile this form. The link will be available also on Facebook and Instagram page. There is an incredible opportunity for the first 25 people that will register. There is an extra visit to Fly Art Laboratory in Polytechnic of Milan, in Bovisa. So you can see with your eyes what could mean programming and working with drones in a high-tech research laboratory. This visit, of course, is suspended until next disposition of Ministry of Health. So when it will be possible to visit in person the laboratory, you will go. The second phase, as I said, is the simulation phase. So we will provide you a Simulink simulator, and you have to design and code control that is able to track the path depicted in the Simulink environment. So the material that you will need is MATLAB, the release 2090 AE or greater, the Simulink support package for Parrot mini drone, and the aerospace block set. But for the rules, you will see that there is a PDF with all of the rules and all of the software that you need in this competition. The phase will end on May the 3rd, when you will submit your code, you and your team, of course, to us, and we will evaluate this code based on some criteria. So the evaluation of the simulation will be, first of all, the completeness of the task. So the task will be the following of the path, and at the end, the landing of the drone. The time of flight, so we will, of course, enhance the drone that will perform the task in the less time possible. And the robustness to different track, because we can change actually the track with respect to the one that you have. Okay, and if more than 25 people will submit the code, only the best 25 will participate at the practical session. What does it mean? It means that since the laboratory, the fly art laboratory, have the possibility to accommodate only 25 people, if more than 25 will submit the code, we have to select, unfortunately, the first 25. So try to do your best. Of course, if the people will be less than 25, no problem. All of you will participate at the practical session. The third phase is the drone competition. So there will be 2 days of test in the fly art laboratory. The first day you will make confidence with the drone, because it's not so easy to connect the drone to PC and test your code. In the second day, you will perform actually the competition. So each group will try to do their best following a path that we will decide. Of course, we will evaluate the best one using the same criteria than before. Of course, we will provide you for these 2 days all of type of accommodation, like food, beverages, and so on, without any problem and without any limits. So that's the third phase. Of course, unfortunately, due to this particular situation that is Italy is facing, we have to stay home, and so the practical test date will be defined according to the evolution of the situation. Could be also in September of the next semester, no problem. You will have more days to test your Simulink. So now a little video on how the mini drone competition is evaluated. I give the word to my colleague Maitri.
Hello everyone, welcome to this video that explains the rules for the MathWorks Minidrone competition. Let us first talk about the problem statement that each team has to work on. It's a line follower using the Minidrone. The Minidrone has a downward facing camera that has to be used to follow the underneath track and smoothly land on the circular marker that is located at the end of the track. The track will have only straight lines and would not include any curved paths. As mentioned in the last video, the competition consists of 2 rounds, simulation and deployment, and each of the teams have to implement the mini drone line follower for both the rounds. Let's talk about the first round of the competition. The participants have to work on a solution and submit their model to us before the submission deadline. The procedure for doing so is mentioned in the rules guideline document on the MathWorks Mini Drone Competition webpage. The first round of the competition will be evaluated on how accurately the mini drone traces the path in simulations, how much time is taken to complete the path, and has the mini drone landed correctly on the circle at the end of the track, along with having code generation capability for the model. The submitted model will be evaluated on different tracks in simulation, and the entries will be judged by MathWorks engineers. Let's move to the next round, which is the simulation and deployment round. For this, there would be teams that would be shortlisted from round 1 and will have to be present on the day of the competition. Each team will be provided with a hardware to work on by MathWorks, and this day will be divided into 2 parts, which would be the practice round and the live round. Let's move to the first part of round 2, which is the practice round. This is mainly aimed at getting acquainted with the hardware, to calibrate and test the hardware. This round would not be evaluated for results, and each team would get 2 slots of 15 minutes. Live round is where the algorithm and the performance of the hardware will be judged. Every team gets 1 slot of 15 minutes in which they can fly their hardware 7 times. At the end of this 15-minute slot, each team has to nominate one of those 7 flights on which they would want to be judged. The teams would be graded based on the number of track sections they have completed. And the judge will decide which stage the mini drone flight has completed, as explained in the next illustration. Let's just go through the flight stages, which would be graded by the judge who will be present on the day of the competition. Once the drone has completed its takeoff, it's stage 0, stage 1, section 2 complete, stage 2, stage 3, stage land, and once verified that it is on the circle, it's stage complete. During the live round, time will be a considered factor only if the mini drone lands on the end circular marker, and the landing will be considered when mini drone's bottom surface touches the circle and stays there. Here are a few examples of correct landing on the circular marker. The first one is a correct one because the entire mini drone has landed correctly on the circular mark, whereas the second one is not because the entire body of the mini drone is outside except the bumper. Hence, the bottom of the mini drone does not touch the circle. The third one is again a wrong one because the mini drone has landed upside down on the circular marker. And the fourth one is a correct one because a part of the mini drone has landed on the circular marker. Please visit the MathWorks Mini Drone Competition website. In case you all have any questions, please feel free to ask us on MATLAB Answers with a tag of Mini Drone Competition. And you all can also email us at roboticsarena@mathworks.com. Thank you and see you all in the next video.
Okay, so what are the key rules for this competition? As you heard from my tree, you have to follow this red path that here you can find the specification, so 10 centimeter of width, and finally land on this red circle. So how we will judge your code? We will evaluate the completeness of your code, so how the drone completed the task, following the line and finally landing on the circular marker. We will test the model, your model, on different tracks with multiple track section. What does it mean? It means that you have to verify that your code is robust to change of path. You can simply, in your simulator, change the different path tracks and verify that your code is robust. The color will be fixed and will be red with this extra code. Finally, we will decide what are the winners and the losers. The model performance will be verified using a tool that we have, so with a standard rules, and we will verify the code generation capability that is required because we need to put this code on the real model, the number of tracks completed, the successful landing of the mini drone on the circular marker, and of course the accuracy that the drone have in the following of the path. Of course, if your drone and all of the drone will complete correctly the path, we will give more points to the one that is completing the path in the less time. The most efficient and accurate algorithm will be the first to go to the second round. Here in the description of this video you can find a PDF with all of the complete rules, so all of the rules that we will follow during the competition, and on the MathWorks website we will link also these videos in the description. There is a series of video by my tree that will explain you how in the basic code the first part of your Simulink block. So now I give the word to my colleague Alberto that will provide you some tips and tricks to perform the best way the competition.
Guys, I'm Alberto and now I will show you tips and tricks of the competition. In particular, I want to show you what are the walkthrough in the Simulink environment and some hint in order to do a code that is more efficient than when you have to deploy it on hardware. Now let's see a little video.
Now let us move to the model that we will use for the competition. Type parrot Minidrone Competition start. This will open up a Simulink project that we will work on, and every time this command is typed, a new Simulink project is created. This is how the model looks like. It has a visualization in which we can view the drone's behavior. Now let us run the simulation using this run button. So this is the visualization, and this is the camera feed that we obtain from Minidrone's downward facing camera. Here the drone takes off, moves to the right until a blue colored box is detected. The algorithm from the flight control system block is the one we will generate code for and then deploy onto the hardware. Now let us explore the contents of this flight control system. The flight control system has two parts, the image processing system and the other one is the control system. Since the two systems operate at different sample times, we have a rate transition block between the image processing system and the control system. Let us see the image processing system. In the image processing system, we have modeled the logic for detecting blue color. We first get the image and convert it from the default Y1U Y2V format to RGB format. We can also convert this image into a YUV format image as well. Here we use the video viewer to view the RGB image that is obtained from the camera. We then perform a small image processing algorithm on the image pixels and then find a parameter that would convey the dominance of blue in the image. In this case, we send a Boolean value which is true if blue color is detected. This parameter is an input as vision-based data to the control system through the rate transition block. Now let us look inside the control system. For the competition, the subsystem the participants are expected to work on is the path planning block. The data from the image processing block is an input to this particular system. Let's navigate inside the path planning block. We have kept the value of x as 0 and the value of z as minus 1.1, which is height of 1.1 meters. And since we have to move to the right, we will just change the value of y. We use the vision-based data that we have got from the image processing system as an indication of blue color detection. This takes a value 1 if blue is detected. Otherwise, it takes a value 0. We latch this output to 1 from the first moment where the vision-based data takes the value 1. In the second part, we constantly keep incrementing y by a specific value until the input value is 1. And the value at the output is what we update in the position reference. We can also use the estimated values which are obtained as an input from the state estimator. One thing to keep in mind is that whatever image processing algorithms are to be carried out on the hardware have to be present in the image processing system, and the logic for navigation and control has to be in the control system. Do ensure that you do not transfer an image or a section of an image as an input to the control system. This is because the control system operates at a rate faster than the image processing system. Now, once we are done with designing our image processing algorithm and the path planning logic, we will have to check that our model is code generation capable. To do this, there's a button in the project shortcuts called Generate Code. When we click on it, the code for the flight control system is generated. And when the code is built successfully, we see this particular sentence. If you need any further information, please go through the documentation for Simulink support package for Parrot Mini drones. If you have any specific questions, feel free to ask us on MATLAB answers with a tag of Minidrone Competition. And in case of any other queries, you can reach out to us at roboticsarena@mathworks.com. See you all in the next video.
Okay, so now let's go deep inside the interface. In particular, I want to highlight to you some key points inside the interface of a project of Simulink. In particular, in the left bottom corner, you can see all the variables inside your project and your simulation. Why it's so important? Because there you can add some type of variables that can be used inside your control system in order to have direct interaction between the variables and the control system. I will show you later how to do it. And on the right top corner, instead, you have all the folders inside this project. In particular, they are very helpful because there you can find all the different steps and all the different codes that are running in the project. Then let's do a little focus on what are the special functions that you can find in this project. In particular, we can highlight three main functions. The first one, clean up project. This is very helpful because if you, let's say, screw up something during your building of your control scheme, you can easily clean up your variable project in order to have a fresh start. And this allows you to avoid to build a completely new project because you clean the current one. After you clean it, you have to set up the new project. So you click set up project and you load the fresh variables inside your workspace. Keep in mind for the third part that your project has to be code capable. What it means? It means that once you have built your control action, your simulator, you have to deploy it on real hardware. How to be sure that your controller can be deployed on the real hardware? You simply click generate code. This is a specific function that builds your code and check if all the functions you put inside it are capable to be generated for the Parrot Minidrone. In particular, if your code is not code capable, so if you click that button, generate code, and it doesn't work, we cannot accept you in the next phase of the hardware part, because if your code did not work, unfortunately we cannot go further with you. Okay, now let's see what are the windows that pop up if we perform the simulator. In particular, we can see that are the Simulink project, so we can see the usual interface of Simulink with all the blocks on the arrows and so on, and then pops up this visualization of the flight simulator. It's important, this visualization, for two main reasons. The first one is that as you can understand, you can see the drone, but this is not, let's say, a simple simulator. These simulators also show you what are the dynamics of the drone, in the sense that show you if there's some type of rolling of the drone, some type of inertia due to some acceleration, and so on. So when you perform the simulator, this is something very helpful to see if your drone is doing something that is real in the world. I mean, if you try to put your drone from 0 to 100 meters in 0 seconds, is not possible, and this simulator show you that is not possible. Okay, now after this briefly introduction of this let's say part, let's do a demo. So this is the Simulink environment. Keep in mind that your controller here will be deployed on some drone bigger like this. So it's like 15 centimeters. Why it's important? Because if you want to analyze the data and the signal coming from the sensor, they are of course provided by some real sensor, and they have some noise on it. So when you build the control action, keep in mind to be as robust as possible in order to avoid some bad behaviors. Also, the image processing system have to deal with a real camera, such this one, and this real camera can suffer from some non-idealities. In particular, I want to highlight you the light condition of the environment, the blur during the image capturing, and also some distortion due to the lens and to the height of the drone respect to the ground. So again, if we want to see this control system working, we can simply hit run. It will compile. Of course, it will take some time to compile all the code because it's a complex simulator, because has also the physics behind the simulator. So you see the drone is going up from the ground, is moving, and of course is going very slow. Keep in mind that if the first try, when you try to program the drone has to be slow, because you don't know exactly what is the control action you want to provide to the drone. And also, again, it's a very small drone. If you have a little bit of wind in the environment, it can have some oscillation. Okay, of course, if you have any question about this control system and in general the part of Simulink, feel free to ask. What I can suggest you, going back to the slide, is that after the demo, you can see that we suggest you to do some prerequisite. What are these prerequisites? They are some easily course that you can find on the MATLAB Academy that cover three main topics. The first one, MATLAB. Of course, you probably know how to use MATLAB. The second one is a little bit less trivial, that is the Simulink ramp, in order to show you all the capabilities of Simulink. And the third one, the Stateflow ramp, can be very, very helpful in order to build a controller for this drone. Stateflow is a software, is a toolbox inside MATLAB that allows you to build a finite state machine. What are a finite state machine? Is something that is driven by events. So you are like, as you can see in the slide, on the launchpad. Then someone, after the countdown, say, okay, go to ignition, and then you go to ignition. Then when it counts until 0, you start the liftoff, and so on. And this is the most trivial way to show you what is a finite state machine. Of course, maybe it can be helpful on this drone, because if you finish the takeoff part, then you start the forward part, and then you can decide to go left, to go right. So it can be very helpful to build the control action. Okay. Moving on, we can see now the organization of this competition. This is very important because you have some deadline in which you have to deliver us your code. So the first one is the team registration. Of course, I suggest you to do as soon as possible in order to go inside the 25 people that can also have a little trip inside the Fly Hard laboratory. And the second thing is the code submission. So once you have registered your team and you have received our confirmation mail, you are officially subscribed to this competition. Then you have to send us the code of this submission of this competition until the 30th of May. Okay, after it, we will judge your code, we will see how it behaves, and then we will send you a mail in order to say if you have win the simulation part, and you are allowed to go inside the drone competition, the hardware part. The date of this drone competition in the lab, of course, now it's a little bit earlier to say exactly when will be, but we will communicate to you when it will be provided. Okay, I want to thank you for the time you give us during this presentation. I also want to highlight that after this presentation we will be online for a roundtable. And in order to join the roundtable, you can find the link below. And also, Daniele, want to thank you.
Thank you, and we are looking forward to see you in person. We hope that we can do as soon as possible the practical competition all together, and have a nice day. Thank you.
Bye bye.